Hi, I'm Richard C. I'm a math tutor here at Wyzant answering a question submitted by a student. This is a question that's basically from Algebra 2, having to do with the natural log function. This is nothing more than log base e. So those of you who are not familiar with this notation, let me just review that. The log notation, when we say log of x, it means log base 10 of x. If we say ln, or the natural log of x, that equals log base e of x. So this is called the natural log. There's two ways to answer this question. They're both involve drawing a graph. The quick way to draw a graph here is just to remember what the log of x looks like. In fact, all log functions are going to look like this, regardless of the base. And they'll all have this graph here. They all go through the point 1, 0. You can see from the graph that there's no horizontal asymptote because this continues to increase here, and you can see you have a vertical asymptote here. And then you would just recognize, so this is the graph of y equals natural log of x. And then if you knew your transformation rules, you would see that this is being shifted. It's called a translation, and it's being shifted right 1 unit. So this is something you should have learned earlier in Algebra 2. So this has been shifted 1 unit. When we shift it to the right 1 unit, we're going to get 2, 0 as our intercept. But now the asymptote also shifts to the right, you see. So here's my asymptote. So x equals 1 is my new asymptote. But the curve itself looks the same. It's just shifted over 1 unit to the right. And that's the way it is. But a translation from left to right isn't going to change anything as far as this question is concerned. You're still going to have a vertical asymptote. It's just shifted 1 unit to the right. And the x-intercept here has been shifted 1 unit to the right. It's still going to have a vertical asymptote here, but no horizontal asymptote here because it continues to rise. So that's the quick way. Now, let's suppose for a minute that you haven't learned these rules for translations left and right, up and down, and so on, and you're forced to plot points. So I'm just going to show you how to do that, and just in case you haven't learned that, we'll just take a few minutes here to show it to you. So I'm going to go back to black now. We're going to start by finding the inverse of this function. So you have y equals the natural log of x minus 1. And now we swap the x and the y. So x is going to be equal to the natural log of y minus 1. And then the next step would be e to the x equals y minus 1. And then the last step would be e to the x plus 1 is equal to y. And so that's our inverse, f inverse of x. And if we were to plot values, x and then e to the x plus 1, and we'll plot, the easy one to plot is 0, because when x is 0, anything to the 0 power is 1. 1 plus 1 is 2, so you get a 2 here. We might want to plot 1 and then maybe a 2 here. We could go with a -1 if we wanted, but let's just stay with this. This is going to be e plus 1. This is going to be e squared plus 1. So on my calculator, I get roughly 3.8 and 8.4. Now, we're not interested in plotting e to the x plus 1. We're interested in plotting this. But because this and this are inverses of each other, all we have to do is swap the coordinates. So what I'm going to plot, instead of plotting 0, 2, I'm going to plot 2, 0. And here I'm going to plot 3.8, 1. Here I'm going to plot 8.4, 2. So let's go ahead and plot those points. So let's say that's 1, 2, 3, 4, 5, 6, 7, 8. So 2, 0 is here, and then 3.8, 1, 2, 3.8. 1 would be something like this, and then 8.4, 2 would be something like this. And let me go and use a different color here. And we would connect these. This is going to be our vertical asymptote at 1 here. And you can see how this is coming down like that. And it's going up as x goes up. It moves gradually up, but it's still moving up the bigger x gets. So we've plotted here x and ln natural log of x minus 1. That's our graph. You can see this green graph looks a lot like this green graph. All I did was I made it a little bit neater because we're plotting individual points. This is more of a sketch, and this is a more accurate graph. But I just wanted to show you how to graph a logarithmic function. What you do is you find the inverse of this, which would be an exponential function. You find your xy points using the exponential function, and then you flip the coordinates and graph the coordinates after you flipped it. And that's the way to do this problem. Either way, we have a vertical asymptote. This one happens to be x equals 1. Here is a vertical asymptote. And we have no horizontal asymptote. So really the basic lesson here is, if you want to solve this problem, draw a graph. And try to memorize what we call the parent functions. This black graph here is a parent function, natural log of x. And then you can graph the child just by realizing this is shifted over 1. And that's the quick way to do a sketch. However, if you really have to plot points, maybe the teacher requires it, or maybe you're just more comfortable doing it this way and you're allowed to do this way on the test, then you would plot your points here and then sketch out the graph this way. Okay, and that's the way. But either way, you want to do a graph here in order to answer the question. Okay, so that's it for this problem. I'll see you again next time. Bye-bye.